Hello, welcome back to the second session of the fourth week of environmental economics. This, by the way, as you well know, we're going to stick, as I said before, to the syllabus religiously if we can, is the last session prior to our first exam. So we will have our first exam on February the 24th, if I am not mistaken. I will double check that and maybe give you only one reminder. But keep in mind that all the material, everything that has been assigned, whether it's only in the textbook or whether it's something that we spoke about in one of these sessions, you are going to be held responsible for. So our first exam is on February the 21st. After that, we will go back to the issue of allocation. But specifically, we'll be talking about the allocation of an exhaustible resource, such as oil, over a period of time. So anyway, our task for today, as we have indicated last time, is really to continue this discussion about value. Let me stress a couple of small things so that everybody will be on the first page, so to speak, on the same page, so to speak. This is an introductory course, and half of the students probably, or a big bunch of the students, are only environmental majors, and so their economics and the quantitative background is not as strong as those of you who are economics majors. So for the purposes of this course, when it comes to the question of valuation, as you have found out, it will really remain the way that it is, essentially descriptive. The solutions of certain small problems will be really limited to what we spoke about concerning the net present value. So everybody is going to be expected to be able to solve a couple of problems using the NPV, and just in order to make sure that you can do a small application. And obviously, if we're going to ask any questions about that, we're not going to require a 20-year period, so you don't need an Excel or a computer or anything like that. We will assume that we're going to be talking about only 2 or 3 periods, so that whatever you have to do as far as the discounts is concerned, it will be really only a very simple operation that can be done either by hand or with the use of just a very simple calculating device. Okay? So the 3 methods that we're gonna describe later on are really essentially methods that require relatively sophisticated procedures of regression analysis, multiple regression analysis for that matter. So the few of you, or the many, I really don't know your background, who might have taken ECHO 240, which is a course that is, you spend the whole semester learning about how to deal with the data of a multiple regression analysis. That is what these 3 procedures that we're going to ultimately be talking about, that's what they are. For this course, we just want to know that yes, there are certain accepted procedures that can be applied, but we are not going to go ahead and apply them because, as I said, just really learning about these procedures will require a full semester. So be that as it may, let us proceed right now to talk about some of these things. I've already made a small list over here. So let's go back to the issue of the discount rate. The first thing about the discount rate that probably I want to stress is just to illustrate one more time, because really at this stage you must become very fluent with the idea of the importance of the discount rate for environmental studies, because it is a very controversial item. Why is it so controversial? Well, to just try to give you a very simple illustration, although the book does a very good example of that. But let's assume that you all have forgotten this general rule of 70 years. The 70-year rule, all what it means is that if things are going to increase at 1%, then they will double in 70 years. So if they're going to double in 70 years, I'm going to be talking right now, obviously all of these are very rough estimates. If they're going to double in 70 years, and you're going to have an interest rate of, say, 10%, how long would it take for it to double then? In that case, it will double in 7 years. Let me make these days sort of a ridiculous assumption that we're going to have a rate of return, say, of 14%. If you're going to have a rate of return of 14%, then how long would it take to double based on that idea of the 70 years? Then things will double every 5 years. So notice what is it that I'm telling you. I'm telling you that if it just so happens that I give you right now the option of receiving $1,000 right now, or receiving a little bit over $1 million in 50 years, which one would you choose? If the interest rate is around 15%. If you had chosen to receive the money in 50 years instead of receiving it right now, because you think that it is larger, then obviously that would be a very clear illustration of the fact that you don't understand the importance of the discount rate. Because actually you should be indifferent. A $1,000 right now and a little bit over $1 million in 50 years from now, if the interest rate is going to be 14%, they are really practically the same. Now, I'm not going to go ahead and do the exact calculations, but why am I saying this? Well, because as we have said, how long would it take then for things to double? Then things will double, what, every 5 years. So in 50 years, how many doublings are you going to get? You're going to get 10 doublings in 50 years. If you have something that is going to be doubled 10 times, how large would it become? Every one will become a little bit over 1,000. So if you start with 1, it becomes 2, 4, 8, 16, 32, 64, and so on and so forth. So by the time that you get only 10 doublings, the 1 would have become a little bit over 1,000. So the 1,000 would have become a little bit over $1 million in 50 years. So as you can see, it isn't very difficult for any of you, by the way, to become a millionaire if that is what you're interested in. Because if you are right now and you're just about to be 20 years old and you want to retire by 70, because probably by the time that you are ready to retire, the retirement age would have been risen to 70, and then you have 50 years. So all that you have to do is figure out what is going to be that rate of return in order to decide whether you're going to get 10 doublings or 5 doublings or 7 doublings or whatever the case might be. And then you would know how much you need to set aside in order to arrive at that particular goal that you have set for yourself. So as you can see, things will grow very, very fast. But the reverse is also true. That is the importance of the discount rate. So a $1 million 50 years from now, if it's going to be discounted at 14%, will become really worth only the $1,000. Actually, if you're going to take $1 million and discount it at 10% over a period of 100 years, it will become really practically even much less than that. It will become probably $100, if not even less. And that is precisely why is it that there is such a great big conflict about what we should do about climate change. Not whether there is climate change. Because as we all well know, most people right now agree that there is climate change, but even then when they agree that there is a climate change as a result of human activity, we disagree whether we should go ahead and undertake a particular projects or not. Why? Only because of the discount rate. If you estimate, say for the sake of the argument, that in 100 years from now, the potential damage to the world economy is going to be, say, $100 trillion. Then what is the present value right now? To try and remedy that, you need, for example, to undertake a particular project that will require, say, for the sake of the argument, $400 billion. So should we go ahead and invest that $400 billion or not? Well, it depends whether that $400 billion that we're going to invest, let's assume in 2 or 3 years, how much of that 70 trillion it's going to be able to overcome, to make us avoid, to avoid from happening. So the only way to do that is to do what? An NPV. You find out what is the net present value right now, of the cost, vis-a-vis the net present value of the benefit. The benefit will be how much of a reduction you're going to get in the damages. If you're going to reduce these damages, say, by 20%, then they become very small. So if they become very small, then you will not be able to justify spending, say, $400 billion or $4 trillion or whatever the case might be. And that's precisely why is it that you have right now these two groups. One of them says that we should go ahead and undertake these major projects in order to try and avoid as much as possible some of the negative effects of climate change, while the others say, no, we really shouldn't do anything because it isn't justifiable. We cannot justify it. So it is nothing else eventually but the discount rate that is going to really decide on whether we should go ahead and undertake certain projects or not. Another thing that obviously is very much related to this will be the issue of the CBA. Because once you do a CBA normally, what you're undertaking a particular project whose benefits are going to accrue over a period, say, of 20 years or 30 years or 50 years. So you need, therefore, to find out what is the present value of these particular benefits. And how do you find out the present value of these benefits? You find out the present value of these benefits by using a discount rate. So those that do not want to undertake a particular project, they will go ahead and they will discount these benefits at a very high discount rate. If you discount the project the benefits at a very high discount rate, then all of a sudden the net present value of the benefits will become small, and if the cost is going to be high and all the cost is going to be, let's assume, spent in the first couple of years, then it would show that the cost is greater than the benefit, and then there would be no need for you to go ahead and undertake that particular project. And that, by the way, was the intention of the Reagan administration when we spoke last time about the fact that the Reagan administration introduced the CBA into all federal agencies with the hope that all of the projects will, especially the ones with an environmental theme to them, will show that really there is no need for them, you cannot justify them, they are not economically feasible. But things didn't work out that way. Why? Because if you still remember, as we said before, from a CBA, it isn't only the discount rate, and it's only a tool. It depends on what is it that you're going to include in the cost and what is it that you're going to include in the benefit. So for the sake of clarifying this again, making sure that it's clear before we leave it behind us, I'm going to give you a very simple example. I don't want to worry about the exact details about when the EPA did a CBA in order to show the need to introduce or to adopt unleaded fuel in the United States. The actual study itself, if you look at the summary, is really a very simple table. It's a table of only around 10 items, whereby the cost is really one item, because the EPA was able to estimate what is the cost of requiring unleaded gas. And the benefits were something like maybe 10 different items, and you go ahead and you added up all the benefits. According to the study, it goes without saying, otherwise we wouldn't have adopted it. The benefits were much greater than the cost. So it was really nothing else. It was very clear that we should go ahead and adopt it. But let's assume, for the sake of the argument, to show you really why the controversy, let's assume that the cost was, and the figures really don't mean anything, I'm going to choose them right now from the top of my head. Let's assume that the cost was going to be $300 billion, and that the benefits out of 10 different items were going to be maybe $1 trillion. So in that case, it's very clear that the benefits are much greater than the cost. But let's assume that only one item in these benefits accounted for $800 billion. So without that one item, then the cost would have been greater than the benefit. But what's that item? Let's assume that that item was the cost of reducing negative health effects amongst children. What if whoever did that CBA did not consider it to be important to go ahead and monetize the negative effects, health effects on children under 12 years old of a leaded gas, for example. And there are some who probably argue that we shouldn't. And even those, by the way, once you agree that we should, it all depends on how is it that you're going to find out, you're going to monetize the value. So as you can see, the controversy really is whether you should add it or not, include that item or not. And even then, once you agree on whether it should be included or not, it is how is it that you're going to go about monetizing its value. And then keep in mind that there are some people that say that we really shouldn't even monetize the value of nature when it comes to these particular items. Actually, in the United States, when it comes to Clean Air Act, we're not supposed to go by the cost. It's only the health effect. If something is going to be harmful, then we should go ahead and take certain measures to reduce its harm, irrespective of whether it's going to show a positive NPV or not. And that was a ruling by the Supreme Court. So we've adopted that particular attitude. So in certain cases, we don't go by the issue of the monetization. But the point, one more time, why is it that we have to go through all of these things? We have to go through them simply because it is not clear whether they should be added or not because of market failures. And then because there are no markets for these goods. So if there are no markets, we've got to find their value. And so right now, the next big issue is, how do I estimate? Oh, let me just mention this. I'm going to show you another very simple example about a CBA. This is an actual example that took place in the town here in Westchester in White Plains. I don't know how many of you are in the Pleasantville campus, but White Plains is one of the major cities in the county in Westchester. Somebody was proposing a big project, and the municipality was in favor of that particular project. So in order to try and sell the project to the people, because many of us who were objecting to the project were objecting to it on the grounds of a CBA. So we forced them to go ahead and adopt a CPA. When they adopted a CBA, I am right now reading in between the lines, I don't know that for a fact, but I think a CBA appeared to show that really there is no way to justify that particular project. So they wanted to justify it. So what did they do? They added to the benefits something that's called the halo effect. What did they mean by a halo effect? They meant that once that project is undertaken, then within a area of, let's assume, 10 blocks, almost everything is going to boom, and rent is going to increase, and all the empty shops are going to be occupied, and so the taxes are going to increase. And so they added a big chunk of money to the benefits that really doesn't exist, based on a very silly assumption that they call the halo effect. And the halo effect you cannot do. You just make any assumption that you want. They made all sorts of assumptions about how is it that business is going to triple and taxes are going to quadruple and what have you. And none of them turned out to be true, by the way. But they convinced the public that there is going to be a halo effect, and so they added to the benefit, and therefore they found out they were able to show a positive NPV. So as you can see, that's why people object in essence to the CBA. But as much as I probably should object to it, I don't, if you still recall, because I cannot get myself to forget that it's a tool. And I can use the tool just as much and as well as the other party can. And very often actually using the CBA as a tool has been very productive even to the environmental community. Keep in mind the example that we gave last time about the West Side Highway in New York City in the late 70s. Environmentalists were against it, and they convinced the judge that the value of the potential extinction of a small fish is much more important than the potential monetary value of having a sophisticated highway, and so the whole project was shut down. So in that particular case, the environmentalists won the case. And it was nothing else but a CBA. Okay, let's go ahead with this. So we're going to limit ourselves, as I said, really only to the descriptive part of the chapter. And the chapter in the book is probably more than enough for our purposes, since we're not going to do any calculations. But in essence, whenever you want to talk about value, about an estimate of value, there are really two things to talk about. We can either estimate it through a direct method or an indirect method. The direct method is when we ask. We go to the consumer and we ask them, what are your preferences? How much do you value this vis-a-vis that, and what have you? The indirect method is that we observe the behavior of the consumer, and we will infer from it what kind of a value they place on that. So let me right now speak very quickly about the three single most important methods that are used all over the world. And they originated in the United States, so they're very common in the United States. And almost anybody who's going to study environmental economics, or even economics for that matter, and is going to probably at one time or another use each and every single one of these three methods. So what is it that we're really talking about over here? We're going to go back to this, to the idea of direct vis-a-vis indirect. The direct is when you ask, So there is only one of the popular methods that falls under that, and that is the CVM, contingent value methodology. CVM has become by far the single most important procedure for estimating the value of a particular environmental asset when there is no market value for it. Because all of these, remember, are nothing else but attempts to try and find out the value of a particular asset when there are no markets for it. And that's why you have a market failure. Now this, as you can see, really goes back almost actually a little bit more than 50 years. The first time it was ever used was in 1963, and it was used in Maine. What it is essentially, that's why I said we ask, it really is a survey. So if you want to find out the value of an environmental asset, if you're going to decide whether a particular project should be undertaken or not, whether it is by Pace University, by the county, by the city, by the state, by the feds, or whatever it is, you've got to come up with a survey. Because we're saying that there is no market, so you're going to have to try and create a market. You want to have to go ahead and get the information in order to try and value that particular item. So essentially a CVM is that you have to sit down and come up with a survey. And the survey doesn't have to be, I'm not suggesting that it's very simple, but it really isn't that difficult, because you don't want to go ahead and ask 100 different questions. Actually, in most cases, probably you want to limit yourself to only something like maybe 10 to 15 or 20 different questions at most. What you're trying to find out will be the kind of preferences that the consumers are going to attach to that particular asset that you're talking about. The difficulty in it, that's why it's very controversial, as popular as it is and as widely spread as it is still very controversial, because you still have a number of environmentalists and a number of economists that are not willing to use it, that say that we cannot depend on the responses that we get whenever we go ahead and we survey the public. And as you well know, this has always been a problem, and we've just finished an election whereby the results of the surveys were completely different than the actual results from the elections. So every once in a while you do have that particular problem. This doesn't mean that the people, by the way, gave you wrong responses. They might have given you the correct response when you surveyed them, but they changed their mind when they were really casting their vote in that particular case. So there are problems associated with this. But before we go ahead, let me also emphasize, why is it that it has become extremely popular and so important? One of the reasons is Valdez. The Exxon Valdez, which is, I guess for most of you, this is something that you might not know about, is the accident that took place in 1989 in Alaska. It was an oil tanker, and the spill was in millions of barrels of oil. What happened is that, as usual, you had the great big fight between environmentalists and between the owners of that particular carrier. And the owner, by the way, was Exxon. Exxon was the owner of the Valdez. So Exxon wanted to just go ahead and clean the beach and pay reimbursement to all the fishermen. However, there is value is not only use value. That is the thing, is that value is both use value and non-use value. We can always find the use value. That's to say, the fishermen have lost a potential income of $1,000 a week for 5 months, and so Exxon will go ahead and reimburse them. That is the use value. But what about the non-use value? What about the fact that these rocks are never going to become clean, and so sightseeing is never going to become, is going to lose in that particular area. Marine life would have suffered damage, and so on and so forth. So the non-use value was never estimated. It was never really accepted as something that should be estimated. What the Valdez did as a result of all the controversies and the suits between the environmentalist groups and Exxon and what have you, is that ultimately the judge, there is a judge obviously involved in this, took the word of the NOAA. The NOAA is the National Organization of Atmospheric Association in the United States. It's a federal agency that appointed a committee to decide on whether the CVM could be used. Because up until now, the CVM, have been used for the past 20 years, but only in an academic environment. So is it going to become accepted as a solution? And the judges then ruled, as a result of the report that was submitted to the NOAA in 1992, that yes, a CVM is to be always used, and a CVM is allowed to estimate the non-use value of the damage that has occurred to an environmental asset. So that is why the CVM is the most widely used procedure, because it's the only procedure actually. There is no other procedure that is allowed to go ahead and estimate a non-use value. The two other procedures are the time cost method and the hedonic pricing, but both of them do not estimate non-use value. So if you're interested in non-use value, you have absolutely no choice whatsoever except to use a CVM. There's nothing that you can do that will be credible, that will be accepted by the courts, unless you go ahead and you use a CVM. Now, what did this panel that was assigned by the NOAA recommend? And it was a panel, by the way, of the top economists in the country. From Arrow down the line, there were something like 5 or 6 really top economists in the country. They made recommendations around 7 or 8. The most important recommendations are 1, 2, 3, 4, 5. I would say these 5 are a must. You cannot do a CVM if you don't take these things into consideration. It won't be credible, and the courts will not accept it. The first thing is that the response rate that you're going to get must be 70%. If you get a response rate that is less than 70%, just forget it. And that's, by the way, a pretty high response rate. Now, how can you get a response rate of 70%? Well, they're saying How do you go ahead and you collect a survey? Well, you collect the data for a survey either by interviewing people, by calling them over the phone, by sending it to them by mail, or these days by email. This panel decided in 1992, and actually the report was written in 1993, and it really became sort of the law in 1994, is that you need 70% response and you must have face-to-face. So the mail and the email and the telephone are not accepted. You must go ahead and meet the people in person and knock at their door and find out what is it that the responses are going to be, and you try to get 70%. If you cannot get 70%, it's not going to work, and if it's not face-to-face, it's not going to work. What is the process that you're going to assume in order to do the calculation? You're going to assume you're going to build that model on the basis that you're going to use a willingness to pay and not a willingness to accept. It must be a WTP. Remember what we said last time, because the willingness to pay is smaller than the willingness to accept. In theory, they must be the same, but all the studies have shown that in reality, the willingness to accept seems to be much larger, in certain cases 10 times as large as a willingness to pay. The other thing to overcome the objection that people take advantage of a particular survey in order to go ahead and either lend support to a particular project that they believe in, or in order to present their objection to a project that they don't believe in. For example, if I want you to undertake a particular project and you ask me whether I'm willing to pay $1,000, I say, of course I am. I'm willing to pay $10,000. And if I object to it, I'll say, no, I won't be willing to pay even a single dollar. So what we do, according to these suggestions by the panel that submitted its report to the NOAA, we dismiss all the outliers. No outliers. Because once you dismiss the outliers, then you're getting rid of the people that are giving you a response in order to make sure that a particular project goes on, and then you get rid also of the people that are trying to stop a particular project. Then the other thing that must be, and I would say that's the last of the 5, that must be done, is that whenever you are asking people about that particular survey, you must remind them always and forever about their budget constraints. So if you ask me, for example, are you willing to pay $100 a week in order to shut down Indian Point? I would say yes. But then you've got to remind me, if you are to pay $100 every week in order to shut down Indian Point, it means that you're going to have $100 less, so you might not be able to go out to your favorite restaurant any longer, or at least not as often. So you've got to remind people that there are budgetary constraints, and they shouldn't just go ahead and forget about them. Now, this isn't probably as important, but I want to go through this very quickly to give you again an idea about how you do this survey. What you have to do really is that you're creating a market. So you're going to set up the market. To set up the market, you've got to explain to the people totally what is it that you're trying to do. What is the project all about? Is it about building a new bridge? Is it about cleaning a particular river, a particular lake? Is it about emissions or whatever? You've got to make it very clear what is it that you're trying to set up. So you set up the market and you explain it very clearly. Then you're going to get the bids. That's to say, you're going to ask them, how much they're willing, how much does this mean to them. And there are a number of ways of doing this. I don't want to get into all the details right now. But as you can see, you can ask them, for example, is this worth $100 to you? And they will say either yes or no. Or you can ask them, you can start from, you can say, okay, is it worth $5? And they say yes. Then you go up to 10, and then you go up to 20 until you reach a particular limit, and so on and so on. So there are a number of ways of getting the bids. And the way of getting the bids, the bid card, could really create a bias. Once you do that, then you go ahead and you calculate the mean willingness to pay. Once you calculate the mean willingness to pay, then you will go ahead and aggregate it in order to find out the bid curves for all of the population. So you've got to decide who is it, what is your population in this case, and you've got to move from the mean curve of an individual to the mean curve of the population. So what you're really doing in essence, you're saying that the price is a function of a person's income, level of education, gender. What did I mean by A over here? I forgot what is it I wanted to say by the A. Let's just say, I mean, all sorts of variables that you think are going to be important. And then you throw in the environmental variable. So this, once you collect that data, let's assume 1,000 different individuals or 10,000 different individuals, this becomes what your data for your regression analysis, your multiple regression analysis. This is what I meant by eventually it really becomes a multiple regression analysis. Actually, most statistics ultimately in the real world really becomes a problem of multiple regression analysis. And there are very many problems related to that, but the very simple ones, I don't want to get into the statistical issue, but the big problems, that the biases of this procedure will be related to the bid card and to the reliability of the bid. So as you can see, one more time, it is a procedure that is used and that is accepted as an estimate of the non-use value, and it is really based on a survey whereby you go ahead and you find out, you ask people about their preferences, and you assume obviously that they're going to be telling you the truth. Now, there are two different procedures that use the indirect. That's to say, we observe the people's behavior, the consumer's behavior, in order to infer what is the level that they associate. These two procedures are essentially the following. The travel cost method, which is really the oldest, it started probably back in the 1930s in the United States, but it really became popular only as of the 60s. What it is, to try to be really very, very brief about this, is that you're saying that the travel cost is a proxy to the value that you place on that particular asset. So where is this used? It's really essentially used in order to estimate the value of outdoor activities. And in essence, really, open spaces and forests and such things. So if you want to estimate the value that's associated with to a particular forest, to a particular golf course, or whatever it is, probably a TCM will be a very good thing to do. What is a TCM all about? You really find out how much we're willing to travel in order to get to that particular park or forest or whatever it is. Would I drive, I know, 10 hours and spend $200 if I don't like that particular park? I mean, that's the idea behind it. So if I am willing to drive 100 miles and 5 hours or whatever it is, and spend $50, then that park must be worth something to me. So what I'm saying is that I am inferring the value that I associate with that particular park by looking at how much of a travel cost I'm willing to expend. So the total travel cost is the proxy. This is as simple as it gets, but as you can see, that is also the problem. How do you collect the travel cost? What is the travel cost? The travel cost, as you might imagine, is going to be the fee that you're going to have to pay in order to get into that particular park, if there is a fee. It's going to be the time that you have to spend driving or traveling in order to get there. It's going to have to be all the costs that you incur in order to get there. And then there is the idea of the compensation of your time. This becomes a huge problem if you happen to be, let's assume, a professional who would have been earning otherwise, I don't know, say $1 million a day. So in that particular case, your trip to a particular park is going to have to mean quite a lot to you. Otherwise, you wouldn't have given up all that potential income in order to go ahead and do that. And so the problem becomes, how is it that we're going to have to estimate that? In most cases, especially for the lower income individuals, it isn't as much of a problem, and the general rule is to estimate something like 1/3 to 2/3 of what is it that they would have earned of the wages as being part of the travel cost. But again, there is a problem. What if it so happens that there is a very important park, but I happen to live only 10 miles away? So in that particular case, all what I have to do is just drive 10 miles, and so the cost is going to be very little. While if I don't live very close by, then although I like that particular park, but because of the time that's going to be involved in getting there, so the issue of proximity of the park becomes important, and then the actual region within which that particular park or forest or environmental asset is going to be located is important. Because if I can take a 50-mile trip and hit 4 different parks that I like, then that will become easier for me than if I'm going to go ahead and hit only one. But in that particular case, what is the cost? Do I take the cost of the total trip and give it to the last destination, or do I go ahead and allocate it to all the destination? So there is this issue of how many sites do I go to on a particular trip. So the multiplicity of sites is very important. The value of time is very important. But all what you wind up in doing really is that you say, I want to find out the visit is a function of the cost, but the cost is a function of the time and the distance. So you go ahead and you collect all that particular data by stationing yourself probably at the entrance to that particular park, and then you go ahead one more time and you run a regression analysis. Once you do that, you'll be able to estimate a demand curve. Once you estimate a demand curve, you'll be able to estimate what's going to be the consumer surplus, so you'll estimate the value that's associated to that particular asset. Now, the other procedure, the third procedure that is also very important and very popular, is that of hedonic pricing. And hedonic pricing, again, really started in the 60s and the 70s. All what it is, and it's a little bit different in the sense that it is really, you're saying that the value is a function of a bundle of characteristics. The single most important probably application of this will be the value of noise. How much damage, how much value do we associate with noise? And the way to do that, we do it by looking at the house. So we assume that the value of a house is a function of a bundle of characteristics. Let's say the size of the house, the number of bathrooms in the house, the size of the backyard of the house, and what have you. But you have, if you take the same homes, one of them on one side of the town and another one is right on the other side of town next to the airport, you'll find out that one of them is selling for $200,000. The other one, which is an exact copy, is selling for maybe $500,000. Why? Because one of them is close to the airport. So in that particular case, really you're saying that the noise is costing you the difference in prices, maybe $200,000 or whatever it is. So you try, therefore, to find out the value of that particular, you have a list of the value of the homes in terms of all the characteristics, the square footage and the size of the yard and what have you, plus either the noise or the proximity to forests and so on and so forth. And you try then to find out the explanation of why is it that although it's essentially the same home or homes that have the same criteria, but one of them is twice as expensive as the other. Because one of them is very close to a golf course, while the other one is very far away. One of them is close to an airport, while the other one is far away, and so on and so forth. So you'll be able, therefore, to assign, to infer the value that you assign to either noise or forests or brooks or whatever it is by collecting all of these. The problems that you run into statistically are really essentially two: the omitted variables, because you don't know exactly what are the variables that you're going to use in order to estimate the value of the house. You will probably omit some of them. And then you have the problem that is known as multicollinearity. You don't know whether there are certain variables that are closely associated together. And so whether to include one or to include the other, it creates a problem in trying to find out the value of the demand curve. And so with this, I will leave you, and you read this chapter, and the week after this, that's to say on February the 24th, we'll have our first exam, and it will be everything that has been done totally conclusive, whether it's in the book or not, whether we have the things that we have posted or to Blackboard. So everything that has been posted, you're responsible for. Okay? Bye-bye.